Hello, my name is Shayan Mitra. I am the faculty member of Department of Electronics and Communication Engineering of Greater Kolkata College of Engineering and Management. Today's topic is about the Unified Modeling Language of Embedded System. So let's begin with the lecture, and the subject code is 704B, and this is the lecture number 33. Okay, so outline is in this lecture we are going to discuss about the introduction to modeling and object oriented modeling, application modeling with use cases, class and object modeling, and state modeling. Okay, so let's begin with the lecture. Introduction to UML, introduction modeling and object oriented modeling. What is modeling, what is object oriented modeling, and what is UML, technical activities in object oriented modeling. Modeling is a customary in engineering disciplines. A model is a simplification of reality. Handling the real world complexity. The four aims of modeling: visualize the system, specify its structure and behavior, provide a template to help. Examples of modelings are textual description, catalog, data book, blueprint, scale model, formal descriptions, equations, finite state machine, set theoretic description, etc. What is modeling? Principles of modeling. The choice of a way of modeling influences how a problem is tackled, how a solution is elaborated. No single model is sufficient. Different levels of abstraction, refinement, and different points of view are also required. One single model will not solve our problem. So examples: models of a house, different levels of refinement, 3D view, rough floor plan with room dimensions, different points of view, architect S view, mansion S view, plumber S view, etc. So what is object oriented modeling? Technical activities in object oriented modeling are: this is the first one. These are the domain analysis, the business model, object modeling, analysis and design, code and unit testing. Application modeling, product definition, requirement analysis, integration validation, maintenance and management. All these points are required for object oriented modeling. So what is object oriented modeling? This is the first. So first, this is the real world. Okay, so from this we will have a domain analysis. So from that the abstraction will created. The vehicle, boat, van, aircraft, basic concepts will be generated from this region. Okay, so we have to create somehow a boat, aircraft. So this is the basic concept, and this is the first aim to create such style. So abstraction will be, after the abstraction will be the modeling, the how the modeling will be created. The vehicle, the form are plane, boat and car. So each and plane, boat, car, each and everything has a model. So in case of simulation we use the data flow diagram, and through that we realize using the code. So data flow diagram and the code, those goes hand in hand. So after that there will be the test verification for both of this realized code and the data flow graph. Okay, after that, if the code run properly, according to that we execute all the operations, and after performing all the operation we go to the real world, where we provided with the basic the models, the real world models of the boat, van, aircraft and cars. So this is the basic formulation or basic flow graph of object oriented modeling. So depending upon the object, what object you are going to create, depending upon that we create the modeling structure, and according to the modeling structure we create the data flow graph and the control data flow graph according, and we also create analyze and synthesize the code, and the code and the data flow graph goes hand in hand. After number of simulation and the test verification, we execute the code, and after that we get to the real world data, and after that we also make a domain analysis. So the product that we have first create, we have a domain analysis of that specific created bodies or the object. So after that we make more improvement and we follow the same path flow. Okay, so let's go to the next slide. Overview of UML, a brief history. This is the Quad, Jordan, Scheller, Miller, Fusion, etc. Bosch is the first, good for design and construction. Rumwag, good for analysis and data intensive systems. And Jacobson is a good for the capture of requirements. So this is the UML OMG request. Okay. So overview of UML. What is UML and what is it for? UML is a language for syntax semantics verification, visualizing, specifying, constructing and documenting the artifacts of a software intensive system. So UML is the artifacts of a software intensive system. So graphics, architecture and behavior, allow code generation, textual and graphic descriptions, all are required. Software intensive systems, enterprise information systems, banking and financial services, telecommunication, transportation, defense, aerospace, medical electronics, scientific applications, distributed web-based services, etc. But also non-software systems, workflow, patient healthcare system and hardware design. Overview of UML. What is the UML model? A use case review, functional requirements, several object views, different concerns, architecture, behavior, different levels of description. So suppose there is a model elements. Okay, so depending upon the model element, what we do, we use the use case diagram. Okay, the class diagrams, the object diagrams, the component diagrams, the deployment diagrams, the activity diagram, the state chart diagram, the collaboration diagram and the sequence diagrams. All these diagrams are being extracted from a specific model elements. So we will go through all the model the diagrams that can be extracted from a specific model elements. Okay, the UML is methodology independent. However, it is better suited to development process that is use case driven, architecture centric and iterative and incremental. Iterative and incremental is a process where suppose we have a product. Now iteratively we analyze and synthesize, basically we analyze the model, and if there is any error or there is a space for improvement, we did that, and we did it rigorously. So that's why this process is known as iterative and incremental. The architecture centric means where we create the whole model of the system. Okay, we create a prototype of model, so that is architecture centric. And use case driven is what is the uses that what suppose we have to create a specific model, so what is the use of that specific model, depending upon that we create and synthesize the structure and the properties of the specific model. So these are the UML software methodologies. So let's go to the next slide. Technical activities in object oriented modeling. Unified modeling language views for technical activities: business modeling, use cases, classes, application modeling, use cases and activity, object modeling, classes, sequence states, analysis and design, classes, sequence states, code and unit testing. These are the we have already discussed all this. Okay. Introduction to UML. Application modeling, product definition, requirement analysis with use cases. Okay, modeling requirements in UML. Functional requirements, model as use cases. Some are specific to one use cases, some relate to technical issues addressed by the implementation diagram and models, other in some supplementary documents out of the UML scope. The use case approach. What is a use case? Set of sequences of actions that a system performs and that yields an observable result. A set of related services provided by the system together with scenarios of use. Example: place an order, subscribe to a service, land an aircraft and pilot a car. Any kind of things. Okay. Actors are anything which interface with the system. People, other system, hardware, software, networks. They are roles, not necessarily full-fledged objects. Actors are usually named by nouns corresponding to the roles. Actors participate or are interested in the result of use cases. Actors are not part of the system. They only the interface with the system. Several sorts of actors: humans, systems, primary and secondary. Primary actors triggers actions in the system, at least one per use case. Secondary actors support the activity, do not initiate it. Stakeholders interested in the action but not necessarily participating. The use case approach, a simplified ATM. The ATM is associated with only one bank. It gives access to all the accounts that customer owns in the bank. Several types of transaction can be chained in a single session: withdrawal, deposit, transfer between customers' own accounts, consulting an account. The customer may obtain a printed receipt for each transaction. The card contains the ID number and expiration date, the expiration date as secret code. The card must be verified by the ATM. The customer cannot make more than 3 attempts to enter the correct code, otherwise the card is swallowed. Interface, keyboard and screen with menus. The customer may cancel the current transaction. The use case approach is simply minimal connection with the bank. When a session is opened, a connection makes it possible to know all the accounts the customer owns. Every night, the information about the current day transaction are transferred to the bank. Manual interventions: an employee empties the machine and or fills it with banknotes, supplies consumables, and does any kind of support requirement or any kind of repairment is required if required. The use case approach: modeling use cases. Informal description, non-human. Describing scenarios, just prose. More formal description: use case diagrams, activity diagrams, sequence and collaboration diagrams. Identifying actors: who uses, installs, starts up, shuts down, maintains the system. Who provides information to the system. What other system use the system. Who has non-functional needs with respect to the system. ATM example: customer, bank, computer system technician, whatever the card. All these things. Informal UC description: top level use cases, a full set of related system functionalities. Identifying use cases: actors, expectation, creating, consulting, updating or deleting system information, notification of an actor state change of an external event, start to end, a complete use of the system. ATM example: handle session, run a customer complete session from start, card insertion to end, card retrieval or swallowing. Transfer daily, nightly retrieval of information by the bank computer system. Maintain, run a maintenance session. Use cases classify the ways of using the system. To each use case correspond to many possible usage scenarios. A scenario is a sequence of interaction between the system and one or several actors. It expresses a particular path to traverse its use case. The scenarios are instances of use cases. Specify use case. Informal. Each use case has generally a primary scenario, typical usage, or several secondary, more exceptional scenarios. A scenario involves one or several actors, usually one primary actor and possibly supporting ones. It may have an initiator, often the primary one. A scenario may be of interest to stakeholders, which are not always participating actors. Example: regulation, policy, board of directors, shareholders. Describe a full use case with a primary scenario and possible variants. Involve a primary actor, a possible initiator actor may be the primary, and possible supporting actors, the interest of some stakeholders. Brief: a simple sentence, a paragraph, informal text, yet obeying simple writing rules, highly structured text, fully dressed. Handle session use case. The customer inserts the card into the ATM. After verification and authentication, the customer may perform one or several transactions. When done, the customer gets the card back and leaves. So this is the Cockburn style in a brief way. Next, use case handle session. Primary actor, initiator, customer, supporting actor, bank. So this is the the customer inserts the card into the ATM. The ATM verifies the card and authenticates the customer. The ATM retrieves the customer information from the bank. The customer selects a transaction among withdrawal, deposit, transfer and consult. After completion of the transaction, the customer may decide to select another transaction or to quit, in which case she gets the card back. If the card is invalid or the customer fails to provide the proper authentication, it could be swallowed by the ATM. For each use case, actors and stakeholders as for informal. Pre and post condition. Pre-condition must be true before starting the UC. Post-condition guaranteed to be true after UC completion. One primary scenario composed of 2 to 8 to 10 steps. Several variants associated with the scenario steps. Other information, exceptions and errors specific are also usual. Specific different information are being exchanged there. Next, primary scenario steps and variants are numbered. 1, 2, 3 in primary, 2A for first variant expressed in informal style of step 2. 2B1, 2B2, 2B3 for variant B expressed in fully dressed form of step 2. For each step, express a functionality in a simple sentence. The subject of the sentence is one of the actors or the supporter or the stakeholders. Use case: handle session, primary actor customer, supporting actor bank, precondition ATM is free. Primary scenario: customer inserts the card into ATM, ATM asserts the card validity, customer authenticates with ATM, ATM gets customer information from bank, customer performs a transaction, customer quits, ATM ejects card and customer takes it. Post condition: ATM is free and all transactions have been recorded. Okay, so next one is these are the different kind of option or opinion that we use to create the process. Handle session: customer, primary actor as usual customer, supporting actor bank, precondition ATM is free. Okay, so basic differences are there. Okay, customer inserts the card into ATM, ATM asserts card validity, customer authenticates with ATM, ATM gets customer information from a bank, customer performs a transaction, customer quits. So here ATM ejects card, customer takes it. ATM is free and all transactions have been recorded. Same here. In case of variance, card is invalid, ATM swallows it. This ends the session. Customer fails to authenticate, ATM swallows the card. This ends the session. The connection with bank is impossible to or interrupted, ATM ejects the card. This ends the session. Customer quits immediately. Customer chooses to perform another transaction. Go to step 5. Customer does not get card back quickly enough, ATM beeps. These are the process. Give a meaningful name to each use case, usually in active verbal form. The name should correspond to the objective of the expected service. Do not model outside the system. Bad customer use cases: choosing a particular ATM machine. Okay. Do not model at too low level. Bad customer top level use cases: insert the card, enter the secret code, get ticket. Select transaction type, select account, select amount. Even worse, push the enter button on the keyboard. Okay, this is the handle session, this is the association customer, this is the supporting bank through which the transfer daily is happening, this is the system limit, this is the maintenance, and this is the initiator. So this is the initiator, this is the transfer daily through with the bank as it is worked as a supporter, and this is the customer which has the association with the handle session. Okay, so let's go to the next slide. The realization of each top level use case requires sub functionalities. Lower level use cases, UC fragments which are not real use cases. Function like decomposition, not really object oriented. Hierarchical decomposition, relationship between use cases. Inclusion, generalization, extension. Include stereotype. The include use case is a mandatory part of the including one. The including UC depends on the included one. Including, this is the included. These are the handle session: verify card, authentication customer, get customer information, and handle transaction. Okay, these are the same thing. Okay, okay. The interpretation of extent varies. The email standard does not specify the nature of the condition at the extension point. Corporate policies may apply. Note the direction of the dependency arrow. The lower level extending use cases depends on the higher one. The higher level one may not depend on the extension. This remark helps to distinguish extend from include. The specialized and generalized use cases are in a sort of relationship. This is the form and this is the handle transfer, handle consult, and handle withdrawal by the handle transaction. It may be convenient to apply generalized to actors. A frequent flyer and a regular passenger are both passengers. Each of them may play the role of passenger in a use case. However, a frequent flyer may interact with the specific use cases. So, depending upon that, the passenger and the frequent flyer and the regular use case, the same thing, Cockburn style, the same process has been occurred. Customer inserts the card, asserts the card validity, authentication with ATM, gets customer information from bank, performs a transaction and quits. The same thing, the same process I explained here. Okay, avoid extend unless specific corporate policy. Usually actors are not repeated on decomposed diagrams unless this can bring some added information interaction of an actor with a specific sub UC, interaction of a specialist actor with a sub UC or specified corporate policy. Do not over decompose. Sub UC should have functional substances, that is in general several significant sub scenarios. Scenarios are instances of use cases. Natural language for expressing scenarios has a strong power of expression, lacks of precision, makes it difficult to express information like timing and concurrency. Need for formal expression of scenarios and use cases. Sequence diagram. Only one scenario per diagram. Accent on the time flow at the use case level. Express scenarios involving the system and some of its actors. May be used also as a mean To model business activity, enter একটা scenarios, activity diagram, several scenarios, even a full use case at once, sort of concurrent flow charts. Formal UC description, UC scenario, sequence diagrams. Customer, ATM, insert card, prompt for selection, select transaction, product result, quit, eject card, and get customer information. This is the bank, this is the ATM, and this is the customer part. Okay. Express a flow of control. Now US scenarios, activity diagram. Express a flow of control composed of action states and connected by transitions. Transition may be conditional. A transition is fired if its origin activity has completed its action and if it is condition is true. Verify date, condition, transition, action state. Handle session UC. Verify card, authenticate customer, get customer info, swallow if it is not authenticated. The swallowing will happen if authentication is not performed properly. And get customer info, the handle transaction, and if it is the not quit, and if you have to quit, then we have to provide a eject response. Now activity diagram, fork and join bar. Express concurrency, fork spawns several concurrent activities, join waits for all incoming activities to complete. Logical concurrency, avoid enforcing non-relevant sequencing. The designer will have the freedom to choose how to implement even in non-concurrent ways. This is the flow diagram. Receive order, establish invoice, prepare delivery, deliver with the invoice. Use interface, accounting department delivery report. The same way, receive order, establish invoice, prepare delivery, and deliver, depending on the process order you see. Okay, the accent is on the flow of control. Describe at once a full set of scenarios, describe concurrent operations, created objects and responsibilities of objects may be represented. They may become too complex, risks to do functional analysis. Organizing the model. This is a top level UC diagram, sub UC diagrams, scenario files, activity diagrams. This one UC use case model, sub 1 model, package hierarchy, sub model. These are the following diagram. Conclusion, difficulty and drawbacks. Use case modeling is difficult. Homogeneity, completeness, and consistency. UML formalism is simple, even simplistic. No real semantics, no formal description of textual scenarios. Need for predefined interpretation, corporate policies. Textual scenarios awkwardly express complex control, loops, and conditions. Okay. Advantages: simple to elaborate, understand, and communicate, even to non-computer scientists. Focus on user needs, not on solution or architecture. Avoid architectural drift in object orientation. Ease traceability from functional needs to implementation. Facilitate setting up integration test. Now here we will continue with introduction to UML, class and object modeling. Okay, object oriented analysis. Analysis model. Object oriented overview, the elements of analysis models, class diagrams, realizing use cases and scenarios, practice of analysis models. Object oriented overview, world of objects. The application world is composed of objects. These objects are linked together. This static relationship. These objects react to stimuli, either internal or external, originating from other objects or from outside the system. These objects have an internal state, internal data, and status of the links with other objects. Object oriented overview. What's in an object? Object is equal to identity plus state plus behavior. Identity of an object. Object should be distinguishable. The identity is independent from the state. Object should be distinguishable and the identity is independent from the state. Internal data values status of links with other objects. Behavior, operations, events, messages. Public interface. Objects have crisp conceptual boundaries. Okay. Static information, architectural aspect, list of operations. The message the object can accept and react to. State values, possible values of internal data, possible links with other objects that are message transport media. Dynamic behavior, control aspect, state evolution and message sent to other objects triggered by message flows. Okay, so we will end our lecture here and we will continue with the object oriented overview in the next lecture. Thank you.